Good afternoon. Thank you for all the participants who stay so late. I know this is the last session of this workshop, and I hope we can have some engaging discussions, and also we will leave some time for question and answer from the audience. Good afternoon, distinguished guests and panelists. As we have already heard from all the previous talks, AI is not just a technological wonder, it's a catalyst reshaping our world. From healthcare to education to entertainment, AI's integration into various sectors marks a turning point in human history, offering unprecedented opportunities and challenges alike. In this panel, we aim to explore the multifaceted impact of AI, its potential to address complex societal challenges, and its role in propelling scientific discovery. So let's engage in discussions with our panelists. Actually, we have already introduced and hear from four of our 5 panelists. And now it's my honor to introduce the 5th panelist of our session, Professor Yasuo Kuniyoshi. Professor Kuniyoshi serves as the director of the Next Generation AI Research Center at the University of Tokyo. He has a distinguished career, having earned his PhD from the University of Tokyo, this university, in 1991, and subsequently joining the Electechnical Lab, MITI, Japan. He actually has won a lot of awards and have been directing a lot of different teams in university and joined the labs with companies. And before going to the topic discussion, we'd like to invite Professor Kuniyoshi to use about 5 minutes to give your insights and future vision you had for AI. Thank you.
Okay, thanks, Asi. So let me start with this, some article I saw on New Scientist last month, saying that ChatGPT, when given a question in Zulu, the language, started to give advices on terrorist attacks. Now, even now, like almost every week, we see a new paper appearing on arXiv on, how to trick LLMs, and then likewise, how to the countermeasure to these. So this technology towards human alignment is really quickly evolving. However, I think this may not reach the ultimate solution. Well, I've been doing research into emergence and development of embodied cognition. And I've been building a model of a human fetus with embodiment and then brain model, and then let it experience the sensory motor process and then develop. Now, we are now thinking of how we can continue on this development towards acquisition of very early sense of morals or conscience. You might think this is a really long horizon thing. However, recently, developmental psychologists discovered that even pre-verbal infants, like six-month-old infants, have the capability of moral judgment and punishing the bad guys. So this is happening pre-verbally, means before acquisition of language. So this is happening not in the language world, but in the real world. So it might be possible to find some continuous line from developing from the beginning to embodied interaction towards acquisition of early sense of morals. This kind of research can be a very extremely transdisciplinary endeavor, encompassing, for example, the liberal arts, psychology, neuroscience, AI, robots, and more. So this can be another interesting opportunity revolving around AI, looking for the future, and this can be, in the end, may mature into something like a constructive science of humanity. So I think humanity is becoming a really important issue, in the light of this really quickly evolving AI. And everybody is thinking about, what's the meaning of being humans, etc. So, and also the human alignment is always very important issue. So my proposal will be to, take up this issue and then organize such collaborative efforts. And probably then, if the research goes on, we might come up with some AI systems with true understanding of humanity that, that will go hands in hands with humankind. Okay, I stop here. Thank you.
Yes, thanks for sharing. So next, we will enter into our topic discussions. We have prepared some topics, but also you are welcome to raise your hand if you have any question you want to ask our panelists. The first topic is about AI's role in shaping future societies. We have seen a lot of presentations before this panel from different perspectives. And we see that deepening integration AI into our societies. So I'd like to ask our panelists, how do you envision a future where AI successfully overcomes current challenges and reshapes different aspects of our daily lives and global systems? So just imagine what we will see in the future if all the AI technology have been successfully developed and they are safe and ethical. I think just any of you want to share, you can just use get your microphone. Or maybe I will name you. Perfect Nagai.
Thank you. So I think that today we have seen there are many research achievement, mainly in the industry side, how the AI technologies can be utilized for advancing for example, the predictions of the many phenomena, and also utilizing their AI technologies for their medical diagnosis. Sorry, it's not the industry, but more in the specific research field. But then I think that if we think about the society, we also have to think about our daily life, how the AI technology will really change our daily activities, especially I'm very much interested in the social interactions with the AI technologies and also robotics. And then if we think only about the language model, as the Professor Kuniyoshi mentioned, the language model is great. I'm also really amazed by the recent large language models. But we also discussed that what is missing in the language model and how we can really connect our experiences with the language models. For example, that we know from their developmental studies that their babies start with their many sensory, their motor experiences, which are not grounded or connected with language well yet. But then they acquire a lot of knowledge and also their experiences, which can enrich our communications. And the language model cannot deal with such multimodal interactions. Language is just a language. It's a kind of like an abstract representation in your brain, but which is not grounded on the rich sensory motor experiences. But our social communications is involving our rich sensory signals, not only just a symbolic language, but also their visual, audio, many tactile sensations, and also an internal state of our body. We also discussed the emotion today, and the emotion is more closely related to our internal body representations. And the question is how we can integrate such rich experiences in our daily life with the recent language model and also the AI. So I think one big issue for us to discuss is that how we can really utilize the AI technologies in our daily life, not only in the very specific like a medical or industry side, but also in our daily activities, how we can really benefit from the AI technologies.
Yes, thank you for the great sharing. Dr. Qiu, do you have any sharing? I think your presentation about wireless and sensing, I think that relate to health and a smart home, maybe.
Sure, yeah, I'd be happy to share. Traditionally, we interact with a computer using keyboard, but in the future, every movement we make, every facial expression we have, every breath we take, every heartbeat we strike can be sensed, including EEG signals. So this sensory information will provide crucial information about our emotion, our health condition, our well-being, and the environment can be adjusted accordingly. For example, if we are breathing very fast, heartbeat increases, then we can notice that the user is under stress. Then the temperature can be adjusted, the soothing music can be played. Meanwhile, if the user speak to the environment, there are certain signs being detected, then we may be able to detect that there's some depression going on or there's early Alzheimer. Then the system can recommend the user to the doctor for early detection and diagnosis. And then currently, the healthcare doctor just prescribed standard medicines. But if we know very detailed information about the user, then we can do personalized treatment. And that will be much more effective. So overall, I think the future healthcare can be revolutionized by the introduction of AI. And doctors now will have a hidden power from the AI, as Peter Lee alluded to in his keynote, that they will have information about all your histories, all the medical images, and vital sign information. And this is well beyond the human memory capability, and they can give more comprehensive diagnosis and treatment. Of course, we need to be careful because the AI system sometimes can also make mistakes. So the crucial decisions still need to be made by the human doctor. But AI will provide very crucial information for doctor to use as a reference.
Yes, thanks for sharing. Yeah, Dr. Bian, I know you present sustainability, but I know you have a lot of work on AI for industry. So can you imagine in the future, if we have advanced AI technologies, how the industry will change, like finance, like the automobile, this kind of industry, what would they be in the future?
Yeah, so today I just talk about our work on AI for sustainability, but as Dr. Xie mentioned that in Microsoft Research Asia, we have very close collaboration with a few strategic industrial partners over a broad range of industrial domains like finance, logistics, energy, automobile, and also healthcare. And we find that given the current booming of foundation models, or we call it large language models, we are able to build a very sophisticated simulation for the whole world. So we are currently working with some partners in the finance domain, and we are trying to use the technology of foundation models to build a market simulation. And given that we are able to simulate any specific scenarios, or even any extreme scenarios in the finance domain. And given that we are able to simulate that and we are able to test our technologies to address such kind of extreme scenarios. And so I think this is a trend that we are able to, based on the foundation models technologies, to make the very realistic digital world for different industrial domains. So I think that will be a very promising for the whole industrial development. Thank you.
Thanks. So any other people want to share? If no, I think maybe we can take one question from the audience. I'd like to mention that actually we have a gift for all the people who ask questions. The gift is from the first speaker, Dr. Peter Lee. He actually wrote a book together with GPT. So I think this, I see someone raise a hand. Maybe the leftmost one, yeah, in the pink t-shirt. Yeah.
Yes, thank you for your wonderful speech. I really get a lot of new ideas and inspiration from today's session. So I would like to appreciate your efforts. And my question is, because I have seen terms like responsibility and reliability of an AI model coming multiple times in today's session. And because I'm from like a software engineering background, so like I've done like software testing. So we come across terms like blackboard testing and like whiteboard testing. And to me, like AI model, especially like deep neural network, is more like a black box to me. So I wonder, like, to what extent can we like comfortably saying that like such a AI model is like 100% reliable and like 100% responsible in a sense? Yeah, that's my question. Thank you.
Yes, thank you. So it's about how we evaluate this black box and also explain the behavior. Furu, do you want to take this question?
Yeah. So actually, I did not work in these areas. I think for software engineering and also for testing, I think this actually has been revolutionized by AI or by large language model in recent years. I think this is one of the most areas that has been revolutionized. I don't think we right now we can truly understand how the large language model works, but that's my biased opinion. I think eventually we can figure out that part. I do not mean that we can truly believe in what the model's output, but I think it will be more and more, reliable. But eventually, for some very key decisions, I think eventually we need to have AI plus HI, and a human will play a very important role, and AI will be more and more powerful tool. Yeah.
Yes, thanks. Yeah.
Thank you.
My opinion is that, first of all, there's no such thing as 100% sure about the neural network system, because neural network system is a probabilistic system, So it's impossible. However, of course, I think you know that nowadays the reliable AI, explainable AI is extremely important topic, and the technology is really quickly evolving. So improvement is really going on. So that's nice. However, I think the issue is, you cannot expect 100% correctness. However, so sometimes the system makes some mistake. Humans even make mistakes, right? What's the difference? So if you look at, for example, some attacks on a LLM, there's some prompt injection technique that, you add some meaningless character sequence, then you can trick the LLM into strange mode. Or, that adversarial attacks on image recognition systems, you can easily fake the system into believing in, something that is not there is there, Now, problem is that even when the system makes some mistake, it's really important that the mistake is still like human-like, that's my opinion. So humans make mistakes. However, the mistakes are also, somewhat justifiable, even though it's not the optimal decision, but still justifiable. But, still current AI systems make really outrageous, mistakes, and sometimes. So that's really the problem, and so we should expect the technological advancements to solve this problem. How we can make the system's peakiness into more smooth, accuracy curve and things like that. Yeah, that's my opinion.
Yeah, thank you. Also, thanks again for the student for asking the first question. After panel, you can come to our people to get your book.
I already get it. Thank you.
Oh, you already get that. Okay,
yeah.
Thank you.
Just on random source, probably one more tiny question. So I think, do we need to first figure out how human brain works biologically before we can actually have a full function foundation model in AI?
Yeah, unfortunately, the person who gave this talk is not in the panel, but maybe, Dr. Qiu can.
Yeah, I can speak a little bit. So it helps, at least from the limited exploration our team has done. So for example, existing neural network, they are basically feed-forward. Most structures are feed-forward. But neuroscientists discovered that for human brain, not only feed-forward is useful, but also feedback. As well as the latent structure. The reason is that, so feedback is the output not only depends on the input, but also depends on the final target. So final target can have some influence in the input. And then, and also, the other structure, the latent structure, is one input can have some dependency on the other input. So it's not straightforward that you have a single, multiple independent input and then get mixed by the feed-forward network. The one input can be influenced by the other input. So our team has designed a circuit net that try to model the feedback and the latent structure as well as feed-forward structure and show that it has improvement over traditional feed-forward only network with much smaller size, but it's able to get a competitive performance. And we from that experience, we do believe that there's something we can learn from the human brain to design the next generation neural network. So Dongsheng has been leading the research on brain-inspired machine learning, and we do want to take inspiration from the human brain, how it works, and to improve over the traditional, for example, transformer and other neural network.
Yeah. Thank you so much.
Okay, Professor Kuniyoshi, you want to add something?
Yeah, that's a very nice approach. So I also really think that it's time to look again at the biological brain and get new insights for next generation AI. Besides the recurrency in the network of the biological brain, I think there are many other things that features that are not captured in the current AI systems. For example, functional connectivity, dynamic functional connectivity. In our brain, a kind of architecture is not fixed for specific tasks. So depending on the input and context, the connectivity, I mean, it's functional connectivity. So it's not just, it's not the wiring that it changes, but the information transmission dynamically changes. and forms a dynamic system for the current situation, current task. So this kind of feature is very interesting and may give really new power to the systems. And there are other things like, subcortical systems, related to emotional systems. And this emotional system is a mystery. And sometimes doing really mysterious information processing that is not modeled in our current models. For example, judging what's good or bad, like a gut feeling. I feel this is good or this is bad. To do this, you need really a lot of information processing, plus looking at the past experience, etc., assess various aspects of the situation. But it's done outside of the cortical system in a very quick manner. So this also might be a very useful function to capture. So there are many other such interesting, exciting aspects in the biological brain.
Yes, thanks, Professor Kuniyoshi. Yes, thank you. I think we will come back to the second topic. So I think we have mentioned brain science, so it naturally come to our second topic is about AI and interdisciplinary integration. We have seen a lot of discussion in previous talk on how AI could integrate with social science, with science, health, and brain science. So considering this AI potential, how do you see, for the panelists, how do you see AI contribute and transforming research and practice in those fields beyond computer science? You can just answer the question from your perspective. Anyone? Yeah, Professor Nagai.
I think that one of the successful field of the integration of the AI research with other disciplines is to utilize AI technologies for analyzing the data, the big data, from medical science, human sciences, and so on and so on. The AI has a strong potential and also big power to more quickly analyze and more accurately analyze using their lot of knowledges. I think the amount of the knowledge that AI can utilize is much more than the human can do. So this is why their AI technologies often show their superior performances compared to the human analysis. But I think that we also have to think about their new usage of our AI, how our AI technologies can also change their human studies or neuroscience studies. For example, I have the close collaboration with developmental psychologists, and of course I utilize our AI technologies for analyzing the behaviors of human children and the interaction with the caregivers. But we also want to utilize our AI technologies to model their human development and also make predictions of the human development. In the early stage of the development, their individual differences might be a little bit smaller than compared to their individual differences in adult. And we hope that if we can model our human intelligence and also the development of the intelligence, we can better predict what happened in the future. Especially as also I work with the researchers who studies their autism spectrum disorders. They want to understand how their differences in, for example, their neural mechanism may contribute or may also affect their social behavior in the future. Once the children are grown up, what kind of difficulties they may have, or how they can also help them to reduce their difficulties in the future. So in this way, I think that the AI has a potential to make predictions, not only like data in the data level, but also the prediction of the human intelligence. In this way, I think that our AI technologies can really change and also make them paradigm shift in our research areas, just providing the new ideas and new hypotheses from the AI field to their other research field. That is the target we have to address in near future.
Thanks for sharing your experience. Yeah, Dr. Qiu.
Our team has been collaborating with several hospitals in Shanghai, and we have some experience about how AI has been used in healthcare. We visited a few hospitals and find doctors need to stare the screen 24/7 in order to detect if patients are going through seizure, which is very dangerous. And our team has developed a tool to automate the seizure detection based on the EEG, the brainwave signals. And that can significantly relieve doctor and so that they can focus on more important things. Beyond the relieving doctor, AI can also be used to train next generation doctors. So for example, we have developed a tool to for seizure detection. Even expert looking at the EEG signals, it's very hard for them to 100% detect whether the patient is going through seizure. Even the expert doctor, it would be good if they can reach 80 or 85% accuracy. But if the AI can provide some relevant example that tagged with negative and positive labels, showing that example related to the current patient will help the doctor better classify the current patients, whether the patient has the problem or not. Beyond that, AI can also be used to automatically generate a medical report. So for example, you have a medical image, X-ray or CT. Right now, we need to have experts, and trained experts are very limited in the number. But by using AI, we can automate the process. And AI sometimes can be even more superior because they can have information about your lab test and also personal history and other things, and more comprehensively provide a diagnosis report. So in the future, we hope that AI can be a powerful tool to the doctor. And of course, this has to be used with great caution. Yeah.
Thanks. Professor Kuniyoshi.
Let me add another aspect. And first, I want to take an example, not from the science, but from board games, Go and Shogi. And you know that nowadays, computer programs, AI programs are really becoming strong and can beat humans, even the highest player. So once I asked one of these top Go players and Shogi players, so what do you think about this situation? And are you going to give up your job? But they said no. It's a really exciting time. So now we have this tool, AI. It's like a rocket, space rocket, that boosts up our intelligence towards the frontier beyond the area that was explored before by only human power. So now we see completely new universe. So this is a very interesting collaboration with humans and AI in terms of intellectual endeavor. And probably, and I think there are already various projects going on in how to employ foundation models to boost up our scientific thinking and exploration into new research issues and hypotheses, because the AI system can, take millions of paper knowledge and also experimental data, etc. So probably these can act as a rocket, space rocket that takes us to a new frontier.
Yes, thanks. Any other panelists want to share? Actually, again, Dr. Bian, I think you have a lot of experience in working together with people from different industries. I think that could be also considered as interdisciplinary. So do you have any experience or learnings?
Yeah, so per our experience in the collaboration with industrial partners, we consider that the interdiscipline between AI world and the other industrial domain lies in the knowledge integration as well as the knowledge generation, which means that we have a lot of domain-specific knowledge that in each industrial companies. And so, for example, we are collaborating with logistic companies to leverage their domain-specific knowledge base to help them build up a foundation model that can help them to address their logistic issues. But the challenge is that how to integrate their knowledge base into the current foundation models. So we are facing the challenges like we may face the domain-specific knowledge maybe in the format like time series data or numerical data or other structure-based data, how to integrate that into the current foundation models. This is actually one of our ongoing efforts that led by another Microsoft colleagues, Dr. Zheng. And so we believe that this is one cornerstone for foundation models to be play a bigger role in the industrial domains. And another thing I want to emphasize is the knowledge generation, which means that given the existing knowledge base from any domain-specific customers or companies, how to leverage the foundation models or large language models to generate new knowledge based on their existing ones. So this is also another our ongoing efforts that we try to leverage the foundation model to automate the R&D process for our industrial partners. And we believe that because of the strong reasoning capability of the foundation models, there will be a great opportunity that we can leverage that to create new domain-specific knowledge based on existing ones. But it also requires a very deep research along these directions. And so we are happy to discuss with any collaborators along these directions.
Thank you. Maybe we can take one more question from the audience. Anyone want to ask questions? Yeah, we have the gift. Oh, yeah, that female student.
I'm a PhD student from University of Tokyo. Thank you for your interesting discussions. I am doing research on rehabilitation, and I will use a machine learning model for motion analysis for patients. However, I think we do not have enough data on people with disabilities for this purpose. Also, patients may have the same disease but different symptoms. I have a question. Do you think AI can cover this diversity of disabilities? For example, do you think it will be able to predict symptoms even if we have never seen before?
Yeah, so your question about sometimes we cannot get enough data for training like disability, and you're asking whether AI can cover these unseen scenarios or with very sparse data. So anyone want to take this question? Yeah.
Let me start with an easier answer. So yes, it's a very important problem. And one technique is to use, for example, so-called physics-informed neural network. Employs, some equation of the physical processes to provide essential information to the neural network that learns. So this way, you can reduce the sample number and increase the accuracy. So in your case, probably of course, you can build, or it's already out there, the model of a human musculoskeletal system. And probably you can even customize that to individual patients. Then use it as like in this PINN to guide the neural network learning. This may help a little bit, you know. So this comes to my mind first. About the unseen novel symptom, I don't know. I don't think, or maybe some generative technique may help, but I cannot think about a concrete solution yet at the moment. So I think it's a really frontier research issue, isn't it? I don't know, but I want to hear opinions from other panelists.
Thank you. Dr. Qiu.
My colleague is doing research on hypernodality detection, and we don't have enough data for hypernodality patients. So what he did is he pre-trained using normal speech, and then fine-tuning using the patient's data. Further, he augmented the data using by adding background noise or introducing some variations in the speech signal. Something like this might be helpful. Not in healthcare, but in other domains, like for wireless data, we also use simulation to generate the data automatically. If you know exactly how the symptom is related to the effect, you might be able to simulate. And in fact, we are also starting to look at if we can simulate some brainwave signals. Yeah, that might be another interesting research direction to explore.
Yeah, thanks. Yeah, Professor Nagai.
I completely agree with the speakers as well, but I'd like to add one more. There are potentials to try to find out there like a common representation or common features from the different modality signals. I also have the same problem with you. I started studying the autistic spectrum disorders, and they are also very diverse and they're very difficult to analyze. And we have limited data, limited participants. And then there are some researchers, my collaborators, trying to find there some common representations from the multimodal signals. For example, if one person has some neural disorders, they may represent their characteristic not only speech, but also the motor behaviors, but also many other modality signals. So of course, I understand that you are starting with analyzing their movement behaviors, but then if you look at the other modality signals and then try to find some common representation among their different modalities, maybe there is a new way to find and analyze your limited number of data.
Yes, thanks, Professor Nagai. I think we need to move to the last topic. Thanks for asking the question. Yeah. So you still have questions? I mean, I'm not taking other questions, but just make sure the question you are well answered.
Okay, I understand. Thank you for your answer.
Yeah, thank you. So let's move to the last topic. We have seen actually AI has changed. The last year, the recent rapid development of large language model has changed the landscape. A lot of areas like natural language, computer vision, system, many other these areas have been disrupted. So for panelists, I want to ask, in the area of large language model, what qualities and approach do you believe define excellence in AI research, and how do these contribute to impactful and responsible advancements in this field? Maybe you can start with Furu, because Furu's team originally working on NLP and now successfully working on big models.
Oh, yes. I think we have seen and been convinced by the so-called paradigm shift of AI technically. And I think there's also the paradigm shift for how we actually organize and conduct AI research. And we can share some learnings. And the first one is I just mentioned. So actually the boundary between AI across different areas, like language, vision, speech, multimodal, actually becomes invisible. And we're seeing the convergence of technology or model, even model, across different modalities like language, vision, speech, and multimodal. So I think we really need to think about the problem more general and fundamentally. And also, it's like maybe in the new age, the best research from natural language processing may not come from researchers in NLP, but maybe similarly, the best work on computer vision may not come from people who are working on computer vision. So we really need to think about in a more general way. And also, I think we should really not work on incremental programs for specific tasks and using ad hoc approaches. And that means even the 5% or 10% improvement is not enough. So we need to really think about the problems that may bring 10x improvements. And usually we need to redefine the settings for those kind of topics. So in general, I think it's best time for AI. So I hope we can make relevant contributions. Yeah.
Thanks, Furu. Any other sharings? Dr. Qiu.
I found that we need to constantly learn new things because AI is advancing at a lightning speed. So every day we need to learn new technology. Meanwhile, because AI has been applied to different domains like healthcare, society, social science, and so on, so we also need to learn the other fields in order to more effectively apply AI to support advance in the other fields. So willing to learn, and it's a very important trait for AI researcher.
Yes, thank you. Yeah, I think maybe we can take another question from the audience. Maybe the last chance to get your book. Yeah, maybe from this side. Yeah. Yeah, the first row.
Thank you for your great talk today. My question is about education on AI. I think there are two perspectives on education on AI. The first perspective is that we need education because our every aspect of our daily life will be affected by AI. But the other perspective is that we don't need the education because like we can benefit from electricity without the basic knowledge of electricity, we can also benefit from AI. So could you tell me, what do you think about education or AI? And if you think it is necessary, how we should make the education system?
Maybe professors can answer this. Who want to take this? Yeah.
Maybe I'm responsible for this question. Yes, you know that there are lots of discussions going on, and your point is really well taken. So, of course, nowadays the discussion is like we should really promote critical thinking because current LLMs ChatGPT, etc., doesn't give you always the appropriate answer, or sometimes slightly mistaken, etc. So you have to have your own thoughts and then critical thinking. And the issue is how to promote such thinking in students. This is important. However, extending your argument, probably in a few years or really quickly, AI will evolve more. so that maybe we don't need to worry about the inappropriateness of the AI outputs. But still, I think then the human alignment issues becomes more and more important. That is this system really thinking and deciding in accordance with the human goods and etc. So if we can trust that, then we don't have to worry, right? So we can really rely on these systems. And becomes really helpful for human society. And I think my opinion is it's the way to go. So that will be the ideal state. So that's one thing. And the technology evolved like this. The computer technology started with, in the olden days, we only had keyboards and the character display. You have to type in commands, etc. And then bitmap display, mouse, and these appeared. And then we discussed. So nowadays you can talk to the system without specific knowledge. But still, nowadays you still need to know how to ask, right? Prompt engineering things. But this is just an intermediate state. So it should be evolve further that any people can just talk to the system without knowledge of how to ask and how to treat the answer. So that's the way to go. That's my opinion. But the AI systems must be really, truly human aligned. That's a really hard problem, I think.
Yes, thank you. Actually, we are out of time, but Dr. Qiu, you can give you some quick comments.
Yeah, quick comment is AI may be able to sense through your physiological signal, know how much you understand, which part each person has understood, and do personalized education. Yeah, so AI can use all this data, not only visual, audio, but also the, for example, wireless sensing data to better understand the feedback and then provide a more effective education.
Just one more from...
I forgot to say some important things. So about the education in the future. So I think, the ultimate thing that humans should maintain would be the capability of, saying I like this, or I don't like this, or I want to do this. So this kind of thing. So your own value system and your own motivational system. These are the ultimate thing that conveys human value. That's my belief. So, and then the future education should be like, not maybe, still studying like, various things is still maybe necessary because to construct some word in your brain is important, but more than that, promote this human values and motivational system becomes more and more important, I think.
Yes, thank you. Since we are out of time, I think it's time to conclude the panel. Thanks all the audience and the panelists for today's insightful discussions. Let's work together towards an inclusive and ethical AI future. So thank you. I will give back to Bai Ning. Yes, thank you.